All right, everybody. I wanted to go over this in a recording so I could give little hints as to how I did the problems rather than you just only looking at the key and not exactly knowing how I got those answers. On problems 1 through 5, I was using inductive reasoning, meaning you're going from specific examples to a general rule. I looked at the specific cases, meaning how we're going from one number to the next over and over, and came up with a general rule. You can see all my answers here. On number 1 is just multiply by 1, then 2, then 3, and so on. The next one is the denominator is just going to be 1, 2, 3, 4, and so on cubed. Number 3 is the planets. I know that's a little tricky if you didn't know the order of the planets. 4 is multiplying by -3 over and over. And then 5 is divide by 1, then 2, then 3, also known as multiply by 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, and so on. Okay, now on these ones right here, instead of just looking at a proof that had all these embedded, I wanted to just put out like, hey, if this was a step on a proof, what would your reasoning be? So the first one is the reflexive property, just because it's something equaling itself. This number 7 is going to be the symmetric property. You're just switching the sides of an equation because an equation is symmetric. Number 8, you had an A, the A went away and a 2 went in. Why? Because you substituted it in. The next one is the distributive property on number 9. Number 10, you're multiplying by something on both sides. So it's multiplication property of equality. Always say of equality if it is happening on both sides. Number 11, that is adding segments and equaling the whole. So that would be adding segments, segment addition, throw in the word postulate. Number 12, I was supposed to have that last piece say A equals D. If it's truly A equals C, it could be transitive or substitution. But if it's A equals D, meaning like there's too long of a train of thought here, A to B, B to C, C to D, A to D, then that has to be the transitive property. Number 13, you guys can see that they have added on both sides. That's addition property of equality. The next one, I don't know why, but I threw another symmetric property in there. Number 15, you can see that the angle A disappeared on both sides by being subtracted away. That's subtraction property of equality. Now this one stumped me for a while. 16 was super confusing to me. The reason being is what ends up happening is the angle 5 goes away and 1 and 2 go into its place because 1 and 2 are going to be equal to 5. But since I was substituting in two things for just 5, for some reason it tripped me up. But that one is substitution. Number 17, that is going to be all right angles are congruent. If they're right, then they're congruent. All right angles are congruent. And that is on our geometry toolbox. 18 and 19 are just talking about the congruent supplements theorem and the congruent complements theorem. That just says if two angles are complementary or supplementary to the same angle, then they must be congruent. On this proof, proofs are a little tricky. Sometimes you're going to get your freebie pieces. So you can see we already have a given here where it says that angle 2 is congruent to angle 3. That's just given. So that's freebie points. And then the other ones, 1 is congruent to 2. If you look at 1 and 2, those are vertical angles. So it's vertical angles theorem. 3 and 4, again, vertical angles theorem, if you look at your diagram. And then what we had from there is if 1 is to 2, and 2 is to 3, and 3 is to 4, then 1 is to 4. That's a train of thought transitive property. Okay, on 21, this would be an example of a proof that I would expect you guys to be able to do on the quiz. It's just basically solving an equation and explaining each piece. The main thing is don't forget, if you have something happening on both sides, you have to have the of equality part. Now on this one right here, the question becomes which given goes first? There's two different spots for givens. The way that I knew that we had to have the 2 and 3 being right go first is because right after it, we're talking about 2 and 3. It wouldn't have made sense to have the 3 is congruent to 4, and then that leads to 2 is congruent to 3. The thing that makes 2 being congruent to 3 is that they're both right angles. The 1 and the 2, you can see they're vertical angles, and you can see the rest of that proof. Now on this one, this is probably the trickiest of the bunch. On this one, that top thing, you are adding together little segments to equal the whole, so that's segment addition. BC being congruent to BC, That's the reflexive property. AB is equal to CD. You have no idea. You glance up and see it is under the given, so it's given. Now, what ends up happening in this bottom right box here is that they are adding BC to both sides. It doesn't matter if you're adding a number, a segment, a measure of an angle. If you're adding it to both sides, it's addition property of equality. And then lastly, what they do is since AB plus BC equals AC, then they erased it and put in AC. Since CD and BC equals in the top left, you can see that equals BD. They just substituted in, and that would be substitution. Okay, these ones can be a little tricky because you need to be able to ignore things. What I mean by that is like, if you are looking at angle 10 and trying to figure out what angles are alternate interior angles, you're going to need to see line 1 and line 2 and line 4 as the transversal. And then what you're going to do is ignore everything else. And that way you would see that 10 and 3 are alternate interior angles. And you would see if you looked at 4 and 5 as your lines and 2 as your transversal, it'd be 10 and 19. We basically do the same exact thing for B, C, and D, but just different types of angles. You can narrow things down a little bit. Like for that first one, when we're looking at angle 10, that is this intersection where 9, 10, 11, and 12 are. In order for an angle to be a special angle, it has to be connected by a line to that other intersection. So the only ones in the running are going to be the intersection with 1, 2, 3, 4, 13, 14, 15, 16, and 17, 18, 19, 20. That top right and that bottom right are not fair game because they're not even connected to the intersection with the 10 by a line. Okay, on number 24, basically you are trying to see, do you have same side interior angles? Do you have alternate exterior? What do you have? And that will help you know if you are going to have congruent angles or supplementary. So A is alternate exterior, those are congruent. B is same side interior, those are supplementary. C is corresponding angles, that's congruent. D is alternate interior, those are going to be congruent. And E is going to be same side interior angles, which are supplementary. The way you can remember that, same side interior starts with an S and supplementary starts with an S. The last ones you guys had to do here were identifying different lines that were skew and parallel to certain lines. Remember, parallel don't intersect and they can sit on a flat surface. They're coplanar. Whereas skew don't intersect, but they can't sit on a single flat surface. It's like a highway and an over-ramp or something. They don't intersect, cars aren't crashing, but they're not parallel. And then parallel planes are a little bit easier. How a parallel plane is going to work is they just don't intersect. So E, F, D, E, F, and D are on the left, so the right is going to be parallel to it. All right, hopefully that helped out to have me explaining things. Thanks for watching.